Good day, class. I remain your favorite tutor, Adeyeye Adeolu Peter. Today, we want to look at the law of conservation of energy, or you call it the principle of conservation of energy. What does the principle of conservation of energy say? It says that in a closed or isolated system, energy can neither be created nor destroyed, but can be transformed from one form to another. As you all know that we have different forms of energy. We have different types of energy. Mechanical energy, we can be divided into two, kinetic and what? And potential. Those of you that pass through the junior secondary school, which is the basic classes, you must have done different types of energy, like mechanical energy, electrical energy, chemical energy, solar energy, and so on and so forth. So we have heat energy also. We have different kind of energy, different forms of energy. But here, we want to look at the conservation of energy. How that energy can neither be created nor destroyed, but can be transformed from one form to what? To another in an isolated system. Now, most of you know this law in your head. You know it as theory, but you don't know the implication of that particular law. So let me show you the implication of this law. If you have a height, this is let's assume this is a cliff. This is a cliff. So that here is the top of the cliff. This place is the top of the cliff. This is top, and this is the bottom of the cliff. Then here is the ground level. The ground level. Now, if you have a mass, let me say a ball of mass m at this height, the top of the cliff, this is the height. Height what? At h. From here to here is height what? At h. Now let me call this top, let me call it A. Let me call the base, let me call it B. And then let me call the center, let me call it C. Now, assuming this height is 50 meters, this is just an assumption. I want to show you how the law works in this particular system. I mean the law of conservation of energy. Let me show you how it works in this system. Now, if this ball is at this height, what is the energy that this ball has? Does it have any energy? You're not sure? Yes, it has. This ball has energy at this top here. And the only energy that this ball possesses at this top, at the top of this cliff is what? Is potential energy. And why does it possess potential energy? The reason why this ball possesses potential energy is because potential energy is the energy that a body possesses as a result of its height from a reference point, maybe from the earth, from the ground. So this time around, this is our reference point. So this ball is at a height from here. So definitely because it has a height, it's going to possess potential what? Energy. Just like this marker is now. Assuming this marker is a big stone, it means it possesses energy. Even as the marker it also possesses energy, but the energy may be small because the mass is what? Is small. If it is a very big stone and it is allowed to fall on somebody's leg, the person is going to feel the pain because of the energy that has been what? Transferred to the person's pain. But the energy is now being felt in form of what? In form of pain. So this ball here has potential energy here because of the height. And what is potential energy? Potential energy, PE, is equal to what? Mass times what? Mass times G times age. Mass times acceleration due to gravity times age. This mass is the mass of the body that is at a height h from a reference point, maybe from the ground, for example. Okay, so we are assuming that age is what? age is 50 meter. So let me assume also that this mass is 10 kg. Assumption, please. Then we know that G is supposed to be 10 meter per what? Per second square, or 9.8 meter per second square, as the case may be. So the only energy this body has here is what? Is potential. Potential is just one of the mechanical energies that we have. You know, mechanical energy is subdivided into two. We have the potential energy and the kinetic energy. So it's only potential that is being possessed here, because it has the ability to do work here if it should fall on anything on the ground there or on the floor here. So now, but when you release this ball, the moment you release it, what happens? It begins to speed down. It will accelerate downward. And as it's accelerating, what is happening? Now the energy is now changing from one form to another. It will be changing from what? Potential to what? To kinetic. From potential to kinetic. What is kinetic energy? Kinetic energy is the energy that a body possesses because of its motion, by the virtue of its motion. So when a body is in motion, it has a kinetic energy. For example, a moving vehicle or an athlete like Usain Bolt, who is on the run. So that such an object is going to possess what we call kinetic what? Energy, because it has velocity. Kinetic energy depends on the velocity. Ke, which is kinetic energy, is equal to half times m times what? Times v squared, where this m is the mass of the body and v is the what? Is the velocity or the speed of the body. So you can see that kinetic energy depends on, it depends massively on what? On the velocity of the body, on the speed. Now, since this body is already going down, so it has possessed it possesses kinetic energy because it already has what? Speed. Now, who can tell me what is the potential energy at the top here? The potential energy at the top here is going to be equal to the mass is what? 10 times, then acceleration due to gravity is what? Is 10. Then what is the height? That's 50. So if you multiply this, what do we have? We have 5000 joule. That is 5,000 joules. 5,000 joule. Then the kinetic energy here is what? Is what? Is 0. The kinetic energy here is going to be equal to 0. Ke equals to 0, because V is equal to what? 0. If you look at this formula, Ke will be equal to 0 anytime V is equal to what? 0. But as the object comes down, what happens? It begins to gain what? Kinetic energy. But what happens to the potential energy? The potential energy will what? Will reduce. Now, if somebody should ask you, what is the total energy at the top here? The total energy at the top is going to be PE max, which is the maximum PE, plus what? KE. And what is the maximum PE here? That's the 5,000 joule that we got there. 5,000 joule. 5,000. Then plus what? What is KE? 0. So the energy at the top is what? 5,000 what? Joule. Okay. Now, assuming we now get to the center, at the center of this height. Now the height is 50 meter. So at the center, what is the height now? 25 what? 25 meter. Now, who can tell us what the potential energy is going to be? Please just follow me. So at this height, what's going to be the potential energy? So if the ball is here now, at height 25 what? Meter from where? From the ground. So the ball will now possess potential energy as a result of what? This height what? 25 meter. So what is going to be the potential energy? Now you will see that the potential energy here is now less than the one we have here. So what is PE now? PE at this point is going to be equal to what? mgh. What's the mass? The mass remains the same, it doesn't change. 10 times 10, then times, what's the height now? 25. So what do we have here? We now have 2,500 joule. You can see that the potential energy has reduced. But does that mean that the total energy we have at point C is 2,500? The answer is what? Is no. The total energy we have here must also be what? 5,000 joule. That's in accordance with the law of conservation of what? Of energy. So the law of conservation of energy, what it's trying to say is that If the energy at the top here is 5,000, the energy at every other point must be what? Must be 5,000. It must not increase and it must not decrease. That is what it means by saying energy can never be created, meaning it cannot increase, and energy cannot be what? Cannot be destroyed. That's it cannot reduce. So we can't have more than 5,000 or less than 5,000 total energy, both potential and kinetic, at any point along the path of the journey of this object. So although we have 2,500 joule of energy at point C, or sorry, of potential energy at point C, it means there must be 2,500 of what? Of kinetic also, because the total energy here is also going to be PE plus what? Plus KE. So can we find our KE here? Can I find our KE? Yes. Let's find our KE. And how do we get KE? At 25 meter from the floor. Now, when the object falls from here and gets to this place, now, what is the distance it has traveled from the top to this place? It has traveled what distance? 25 meter. That's half of 50 meter. So it means we also have a distance of 25 meter. That's h equals 25 meter from here to here. That's the distance traveled, because we consider the object falling freely from here to here. And when an object is falling freely, please, here we are going to need the knowledge of projectile, because we have to find our velocity here, the velocity that the object has already gained by traveling from here to here. Now, what is the velocity initially here? Initially, since the object is falling freely, what happens? U is what? 0. The initial velocity, initial speed is going to be equal to what? 0 for a free falling object, from the knowledge of projectile. But as the object is coming down, the speed begins to do what? It begins to increase downward. So we must know the speed now after it has fallen what? 25 meter, and it's now also at 25 meter from where? From the ground. So let us get the speed at this particular point. So what is the formula for that? That should be the third equation of motion. V square equals what? U square plus 2GH. Now we are using plus because the object is gliding freely with what? With gravity. It is not moving against gravity. Since the object is falling down, we are going to be having plus. It is when the object is going up, we are going to be having minus. So this is the speed now at point C. So V square will be equal to, what is our U? Initial speed. Since it's a free falling object, U is what? 0. 0 square plus 2 times 10 times what? Times h. What is the height falling through, the distance traveled? That's what? 25. So V square will now be equal to 0 plus 50 times 10. That's what? That's 50 times 10. That's 500. So V square equals 500. So I think we should just leave it this way. So what is now going to be our KE? KE, if you want to find the velocity, you can do so. You can do so. You just find the square root of 500. KE is what? Half mv squared. So let's calculate our kinetic energy here. That's half times. What's the mass? The mass remains 10. Then what is our v square? V square is 500. So let's deal with this. Half times 10 times 500. That's what? 2,500 joule. So you can see that the kinetic energy here is what? 2,500 joule. And the potential energy is also what? 2,500 joule. So what is now the total energy? That's what? 25 plus what? 25. And what do we have there? So the total energy is what? Is equal to 5,000 joule. You can see how we prove the principle of conservation of what? Of energy. I can pick any other point again. And I pick another point. Now, down here, what do you think the energy here is going to be? Down here, the energy here is still going to be what? 5,000. That's potential plus kinetic together. But let's break it down. What is our kinetic here? Our kinetic is going to be maximum here. We are going to have 5,000 as our kinetic. Why potential here will be what? Guess what? 0. Now, why is it that potential here will be 0? Because it's already at the ground. And the height is what? Is 0. So mgh, that's PE, equals mgh. So what is our PE here? 10 times 10 times. What is the height on the ground? That's what? 0. So that's 0 what? 0 joule. But what do you think our kinetic energy is going to be? We have to go and look for velocity again at the ground, or just before the object reaches the ground. So we have to find the velocity that the object has already what? Has already gained. So we use the same formula we use here. V square again equals to U square plus what? 2gh. So which is now 0 square. That's from here to here. For the object to have traveled from here to this place, we want to see the total velocity it has gained. Then plus 2 times 10 times, what is the height? This time around, the height is what? Is 50. That's going to be what? 5, 0. No, that should be 100 times 10. So we have V squared to be equal to what? 1000. So what is now my KE? KE will now be half mv squared. That's half times what? What's the mass again? 10 times. What's my V squared? 1000. So if you calculate KE, is going to be equal to what? 5,000 joules. So you can see that our total energy here is still what? 5,000 joules. So you too, you can decide to pick any point. Maybe pick 20 meter from as you know, and down the cliff. Pick 20 meter down the cliff. Calculate the potential energy there. Calculate the kinetic energy there. Add it together. The sum must give you what? 5,000 joules. So that is the proof that the law of conservation of energy is what? Is correct. Very perfect. So energy can neither be created nor destroyed. They can be transformed from one form to another. Thank you.